So hi everyone and welcome back to our online live meetup. This is the second talk that's going to be presented by Stefan Kemp. And Stefan is going to talk about multi-platform development with Kotlin. So please Stefan, take it away.
Thank you, Betjan. So, hi guys. Let's start first with a very short story. Let's assume that I am hired by an external company. And that company has a brilliant idea. It is crazy. It's new. It's about making a social media platform on which you can share videos. And it's short videos, videos of like a 10-second length. And those videos can be shared across with your friends, basically. And your friends can like those videos, can leave comments on those videos. And once I was invited to join a birthday. You know probably how it goes. You're asked, "Hey Stefan, do you for a living?" And then the exciting part begins, right? Because the one that asks you that question has no technical background, and how are you going to explain him what you are doing? So usually I ask for a piece of paper and a pen, and I start drawing on the paper what I'm doing. And it could look like this, basically. I have drawn an Android application for our Android users that we are targeting with our social media platform. The same for iOS and for everyone else who are using browsers or behind the laptop. We have a browser app running as well. And I also explained that those three platforms, those three apps, are all connected to a backend. And the backend is storing all our videos and is giving us a timeline with all the videos from our friends. And as we continue our talk, I also explained to him that it's not just one Scrum team that is actually working on this, but there are many more Scrum teams. So together with that and all the teams that are working on the platform, we have quite some business logic that we are building with each other, right? It's growing, the app is growing, it's getting more popular, people are using it, and as we are developing our business logic, we will also encounter that we have some duplication. That's mainly also because we don't have a single code base. So all the business logic that we write has to be duplicated across those apps. And as also the complexity grows over time, we have more maintenance. And having more maintenance means basically that also our costs will grow. And usually my experience is that the manager at the company, who's mainly looking at the Excel sheet, is basically seeing that, hey, it's getting too expensive. It slows us really down, right? We have so much duplication and maintenance that it will really hurt us to be competitive in the market. So what will happen? The manager tells the developer to come up with a solution, and the developer, of course, as how it goes, says, "Hey, no worries, we'll come up with something." Well, I have visited, for example, last year a conference, and I saw him talk about Flutter. I read a blog post. It's about React Native, and I heard a colleague telling me about Ionic, which is also awesome to maybe look at. And there are many more frameworks, SDKs out there, which we can use to reduce the complexity, reduce the duplication. And those frameworks have in common basically is that there's just one single code base. And from that single code base we can generate our applications, and by having a single code base we have less duplication. And with less duplication there's also less maintenance. That in the end also means that we have low costs, especially on the long term, because if we did that transition to the new architecture by supporting new framework, it will lower the cost because of having a single code base and there's less maintenance. But how about the programming language? For example, for Flutter we have to use Dart. And for React Native we will be using JavaScript, which is probably fine because we already have a web app running. But for Ionic we will be using TypeScript. Now TypeScript on itself is not so very different than JavaScript, it's more type safety. So we'll be fine with that. But that is something that you'll have to keep in mind. Also important is that we had that backend service running in the background. And it might be interesting to also share code not only in the front end, but also in the background. So things that you can think about are probably something like validation rules. So you have to log in or you have to make an account. So there's some validation on, for example, the password complexity. And those rules should be shared across your entire architecture as well. The third critical question that raises is if you could really use the latest mobile SDK feature. And it depends basically on the framework that you'll be choosing in the previous slide. But if you are depending on the vendor to first update its own framework or SDK before you can use the latest biometric possibilities in iOS, or maybe the augmented reality SDK that is released in Android, then you might also have an issue. The last critical question is about the native user experience. So not every framework or SDK in my previous slide is actually compiling to native user interface. So the question raises what is better, right? If you would ask a native developer, he would say always go for a native user interface because that responds better, it feels better, it's faster, so go for that. So that's what you have to keep in mind as well. And actually those four points might be covered by Kotlin Multiplatform Mobile. So before I go into details and explain what Kotlin Multiplatform is and what Kotlin Multiplatform Mobile is, let's introduce myself first. So my name is Stefan Kemp. I'm working for Open Value as a full stack developer, and I love the craftsmanship of software development. And I've been doing that for a while now. And I've been working with backends, writing in the Java programming language. I've been working with Android applications, iOS applications, and lately also with websites. And this is also my very first meetup. Exciting to be here, to tell you more about Kotlin. So if you have feedback, leave that also in the chat. I'll read that afterwards so that I can improve myself as well. So I'm working for Open Value, and I know that there are some Open Value colleagues in the stream watching over here as well, and they should be scared now because I'm going to show them a couple of pictures, but that will be later. We have once a year a hack weekend, actually it's a couple of days, and during those days we are allowed and can work on projects that we love to work on, and that are usually projects on which you don't have time during the weekdays with the customer. And during those days you can play around with, for example, artificial intelligence, or do something with machine learning, or maybe you have some Raspberry Pis at home that you would like to try out. And the main thing here is that it needs to be fun. And last year we went to we went to Belgium, so we had a hack and bike. But this year, because of COVID, we stayed in Holland with the company. So we had a hack in Hollandia. And this is how it looks, basically. This is Bert-Jan.
So who's there pretending he knows how a soldering iron works?
He is doing some stuff with hardware. During that weekend, there was also Formula 1. And I'm a big Formula 1 fan, so we did put the race on the screen itself and been watching Formula 1 with the group, and that was fun as well. Yeah, it was not the race itself is not really it wasn't a good race because Max Verstappen, for example, didn't even make turn 8 or turn 4 because he crashed. So it was quite boring, but that's how it goes, I think. We also have some colleagues that are quite sportive, so they went out on the bike and did a ride of like 150 kilometers. Really respect for them, of course, that they can manage to do that. This is me sitting in the grass.
In your natural habitat, I would say, Stefan.
Yeah, exactly. Yeah, this feels comfortable. This is really cool. And yeah, I had several things to look into, and during actually the last days of our hack in Hollandia, a colleague told me about Kotlin Multiplatform Mobile, and yeah, that's actually how it started for me. So I was curious what it was. So yeah, Kotlin Multiplatform Mobile. That's where it began for me. And yeah, when you search on the internet, because you are curious what it actually is, you'll be maybe yeah, you will be finding this blog post by Ekaterina. It's published in the end of August. Actually, it's more September, and she is actually sharing that Kotlin Multiplatform Mobile with the world in the alpha status. And that's a very nice article. So I actually did a copy paste of a snippet from that article. Let's read it out. It's about Kotlin Multiplatform Mobile. It's an SDK for cross-platform mobile development provided by JetBrains. It uses the multi-platform capabilities of Kotlin and includes various tools and features designed to make end-to-end experience of building mobile cross-platform applications as enjoyable and efficient as possible. So that's quite some text, and let's zoom in a little bit. So it's an SDK for cross-platform mobile development. It's using the multi-platform capabilities of Kotlin, and according to her, it's enjoyable and efficient. So I'm also curious after the presentation how you look at it. For me, it was at least very enjoyable to play around with it. So multi-platform capabilities. I don't really have a lot of experience with Kotlin. Actually, during our hack in Hollandia, it was the very first time that I did something with Kotlin. So I basically also learned a new language. It was fun, but yeah, next to that, the article itself had a lot of questions for me. This one raised out as well, because multi-platform capabilities, Kotlin, what is that? So if you search on the internet, Google knows the answer, of course. You probably find this diagram. It's on the page from Kotlin itself, on the documentation pages, and it explains it actually pretty well what Kotlin multiplatform is. All the magic basically happens in the center. Over there we have Common Kotlin. Common Kotlin is basically including the Kotlin language itself and some core libraries. And there's something very important about this, because Common Kotlin, the code written over there, should work on all platforms. That is basically the rule. And if you follow that, you will be fine. Next we have in the second ring Kotlin GVM, Kotlin GS and Kotlin Native. And those are platform-specific versions of Kotlin, and they include an extension of the Kotlin language, and are basically forming also a bridge to the native code, for example, which is in this third ring. Or if you are using Kotlin GVM, you can access the GVM code itself. So if you want, you can use the classes in the util package. And for Kotlin JS, you can actually access everything what is available within the browser. So you can interact with the window object or the navigator and play around and do things with that. And this is actually the very basic overview of Kotlin multiplatform itself. Ooh, this looks awful. Let's fix it. Here we go. So which platforms are actually supported by Kotlin multiplatform? Well, we have already seen Kotlin GVM, and we have seen Kotlin JS, but then there are a bunch of other platforms, and those are basically grouped by Kotlin itself to be Kotlin native. So from the previous slide I was talking about Kotlin native. Well, those are the platforms that belong to Kotlin native. So that is Android, iOS, watchOS, tvOS, macOS, Linux, Windows, and even WebAssembly. So that's quite some list, and that basically means that you can, in your single source code, target each one of them if you want. So that's pretty cool. And you might be wondering now how that looks. So what we are going to do, we'll be switching to IntelliJ. There we go. And we are going to create a new project. There we go. Over here, we are selecting Kotlin, the language. And in the middle, let's make it a little bit bigger. Here we go. We see that there's a section that's called Multiplatform. And over here, for this demo, we are going to select library. And the project GDK will be version 14 for now. We'll go to the next slide. And this is basically what will be generated if I click the finish button. And over here I can tweak the targets a little bit. So we'll be going to create a library. And the library consists of the common, that is the circle, inner circle in the middle of the diagram. The GVM target, the browser itself, so the Kotlin JS, and native. And for native, I'm going to change the template to native application so that I'm able basically to run the native code on my computer. Otherwise, it will do nothing because it's a library. So let's leave everything else as default and finish. And now IntelliJ will generate a project for us. It says it is already existing. Let's start over. There we go. So I'm going to give it a new name. Not Untitled, but it is Open Value Meetup. Library project DDK is number 14. And I'm changing the template for native to native application, finishing it. Also already exists. We will see what we get. This doesn't look good. Let's try it one more time. It's in alpha status, so it is expected. New version. Here we go. This should work. I've never done this before. So next, changing the template again. Finish. There we go. This looks more promising. Let's wait till Gradle finish the build.
If it doesn't work the first time, then it's not worthy of an alpha version, right?
Yeah, exactly. So it really proves that it's an alpha version. Okay, so we have our project now. It's different than we saw earlier. So what did we get in IntelliJ? So there's a build Gradle file. Let's go down over here. And the first thing that you can notice is that we will be using the Kotlin Multiplatform plugin in our build Gradle file. Next, there's a bunch of things which are less important, but over here in Kotlin we'll be actually defining the targets that we have for our multi-platform. So first we have GVM, obviously. We also have a target for JavaScript, the GS. And finally there's some more complex code, but this is for the native target. Based on the operating system on which your machine is running, there's some dynamic code over here, so it is trying to, based on the operating system, see which native target it should be. So it can be either Windows, macOS, or Linux. Over here, if we scroll down a little bit, there are the source sets defined. And these are basically also the directories that you'll be seeing in the source directory. So we have common GS, GS main, GVM main, and native main. And if you have some dependencies specifically for GVM, for example, you can add it over here. This is basically for the test. But this is actually what you have to look into if you have platform-specific dependencies. So back on the left side, we have the common main, which is empty. Same for JavaScript, GVM, and native main. And what we are going to do is we are making a generator, an UUID generator. And for that we have to need a generator class. Here we go. And over here we declare a function which returns a string, and we can say my very cool UID. Here we go. This is it for now. So in the common we are done, and we can basically in the other projects now call the function which is in common. So in JavaScript we'll be making a class. Sorry, just in a Kotlin file. Let's call it main, and the function is also called main. And over here we are going to have a print line which is saying hello, this is the Kotlin GS target, and another print line to actually print the generated UUID. And because it's all Kotlin, we can copy paste the main file to the GVM target. We are going to change the first print to Kotlin GVM. And for native main, there is already a main file, so we are going to update it a little bit to also generate the UUID for us. So let's start with running the native main project. It's getting confusing maybe. This takes a while. Okay. And in the output, we see that the hello Kotlin native is printed with my very cool UUID. Same thing, of course, for the GVM target. Let's run that as well. Here we go. But this is the output for the GVM target. For JavaScript, it's a little bit different because we have to make a build first. So I'm going to do that right now. Let's build it. And the Kotlin GS platform specific version will actually now in my build folder in the GS directory in packages open value meetup new version, which is the name of my project. In Kotlin write as an output the JavaScript, which is generated. And over here, if I inspect it, you'll be seeing that the generate UUID function is here, but we also have that main function that I've been making in my main Kotlin file. So this is pure JavaScript basically, and there's some boilerplate around, which is basically calling my main function. So I can now run this JavaScript file with Node, and I'll be seeing the output over there, which is saying, hey, this is the JavaScript target and my very cool UUID. Yeah, and this is actually the very basic, the very basic Kotlin multi-platform project that you can have. And it looks like this. We have just created a common main project. We also have a GVM main, JavaScript main, and a bunch of native main targets. And as you can see, they all extend basically from common main. So the trick is that of all the business logic that you want to share, that is what you want to put in common main, and everything else can then be reused. So this also raises the question: what if you have platform-specific APIs that you want to access from the common code? This is something that happens quite frequently, because not everything, you cannot solve everything just within our common code. Sometimes you need some interface or some logic which is only available in the GVM code, etc. So like the Kotlin boys actually have a solution for that. They came up with the expected and actual declarations. This is also in beta, so yeah, let's see how that goes. But it basically looks like this. In our common project, we are declaring that we expect a function or a class. It doesn't really matter. And in the target, like iOS or Android, we must implement the function itself with the actual keyword in front. And over there we can use the native libraries or use the GVM libraries. It depends on what you actually need for a use case. So we are again wondering how that works. Let's go back to the EDA.
So we have a question in between, Stefan. Yep. A question about you showed Gradle to perform the build. Can you use Maven as well?
Good question. Let's check it out right now. I don't think so, because the only supported options are Gradle Kotlin and Gradle Groovy. And as you can see, Maven is disabled. So I think maybe it's the alpha status and it will be supported later. But for now, only Gradle is supported.
Yeah, it might depend on some plugins maybe that are not there for the Maven ecosystem yet.
Exactly.
Okay, thanks.
Okay, so back to our example. We are going to refactor our generate UUID function by having that expect actual declaration. So I am putting expect as a keyword before the function. That also means that I cannot implement the function over here, so I remove the implementation itself. And you see that my EDA now starts complaining. It's saying that the expected function is not there in the target GS main, and the same for GVM main, and the same for native main. And that makes sense, right? Because it's expected, but I haven't done anything else. So we'll be implementing that. Let's start first with the JavaScript implementation. We'll be using the help of IntelliJ to generate the actual function in our GS main target. And over here, I can say, for example, let's make use of the date, the date object which is available in the browser. And I'm going to get, for example, the time, which is in double, and I have to do a toString to conform to the interface, just for demo purposes, to enable me to basically get an UUID in JavaScript. So that is one error less. Let's do the same thing for GVM, but instead of having dependency on the date, we'll be using the UUID class from the Java util package, which is only available in the GVM target. And let's see. This is the, oh, there we go. And we also have to call toString on that. So over here we'll be using the UUID from the Java util package. You might know what is coming about for the native code. Let's use the NSUUID, which comes from the Platform Foundation package. And let's see, that is the UUID string function, which I have to call. And this will basically generate a UUID with using the NSUUID class from the Platform Foundation package. So let's close it all. My error is gone because I've actually implemented all the functions. And let's start again with the native code. There we go. This is the output. The first compile seems to be longer than the second run. So if I keep running it, I will get a different UUID. Same thing, of course, for the GVM target. Let's run it as well. We'll be getting different UUIDs. And for the JavaScript target, I have to make a build again. So IntelliJ is helping me out here. Let's wait for that. Go down the directory path to my generated JavaScript. And you'll be seeing that the generate UUID function, which was expected before in common, now actually contains the implementation itself as it is actually being implemented. So there's no weird things going on over there. I can run it just for the demo. You'll be seeing that there's a timestamp of the date printed. And that is basically how you could use the expect actual declarations in your code to fall back to the target itself to solve complex issues.
So we have another question, Stefan. Question from Dan. Do you write the native Kotlin code in this project, or is the native code generated like the JavaScript code?
It is generated, yeah. So in the, let's see, in the build directory, you will also see that there's an, let's see, where is it? Over here, I think this is the generated file for, I think, iOS, for the macOS.
Thanks.
Yeah. So back to the Kotlin Multiplatform mobile. We've been learning about Kotlin Multiplatform, how the basics are. Let's see how that works for mobile then. Well, for mobile, they are actually depending on the same way of working as for Kotlin Multiplatform itself. So this diagram, on the bottom, you're seeing shared code. And in the shared code, just like for Kotlin Multiplatform, you can implement your business logic. And if there's a need for that, you can actually fall back with the expect actual declarations to use iOS specific APIs or Android specific APIs. And that together is the shared code that you can use in the native code on top. So we'll see that also in a minute, and we are going for our third demo. But the native app that we are going to make is just built in Swift. Swift is one of the languages for making an iOS app, basically. And for Android, we'll be using Kotlin. And those two projects are depending on the shared code, where we have that business logic that is shared. So Yeah, I already said it. Let's make an Android and iOS app that has some shared business logic. There we go. We are not using IntelliJ for this demo. We'll be using Android Studio. Okay, so the first thing that you have to know, you have to install Android Studio 4.1, and there needs to be a plugin installed that is called Kotlin Multiplatform Mobile. If you have those two on your machine, you're probably ready to go to make a multi-platform mobile project. And we can do so by selecting Create New Project. And as a project template, we will be scrolling down and you will see that the Kotlin multi-platform mobile template is there. We'll go for that. Next, we should give it a name, like open value meetup. The package name is fine. The same for the location where the project is stored. The minimum SDK is API 16. So with that we are supporting like 99.8% of the devices. We'll select next. Over here we'll be having an option to change the name of the Android module. Same for iOS or the shared module. This is also something that can break, because if you put the name over here that contains spaces, then we are able to continue to the next step to finish it, but in the generation itself will fail. So let's hope that that will be fixed later to have some proper validation on that. So we'll be using the defaults over here. And let's generate our project. Let's wait till Gradle is finished. Shouldn't get too long. It's finished. The indexing part can continue in the background. We'll be switching to the project overview, and let's see what we've got. So first is the shared directory, and the shared directory has basically the same build Gradle file as if we've seen in the previous example, and over here the Kotlin multi-platform plugin is defined. Over here you also see that we have two targets over here. It's the Android target and the iOS target, and well, we have a bunch of source sets. So we have the common source set over here, the Android source set, and we have the iOS source sets. So in the source directory, same thing actually, right? It's the Android, common, and iOS. And this this project template that I've been using comes with some some generated code. So there's a greeting class that is that has a function greeting that says hello. And it's using the platform class to call the platform property on, and it's actually next to the greeting class. And this is an example of how it looks if you have an expected class. So the common main over here expects that the class platform is magically there, and that the platform class has the platform property defined. So let's go to Android main in our shared directory, and of course it's implemented over here. So this is the actual class platform with the actual platform property, and as you can see, it is importing from the Android OS package the build class, which contains a version constant that is having the SDK int over there. So this is basically telling us the SDK version on which the app will be running. And for iOS, the same thing. The actual class, we are still in Kotlin, of course, but over here we're importing the UI device class. We'll be giving the platform property, the system name, and the system version. It is the iOS way of showing which platform we are on. So some basic code, basically not something new. But this is where also the exciting part comes in, because there's also an Android app and an iOS app directory. And not sure if you did some Android development lately, but this is also what you will get if you generate an Android project. So there's an Android manifest over here, which contains the application, some details about the application, also some details about the activity. I can do whatever I want. I can give the activity a name, for example, like open value meetup. That all works fine. There's a REST directory, which contains the XML files for my activity and for the colors and styles that the sample application is using. And the main activity, which is in the Java directory, it's a bit confusing, but that's how it goes, I guess. We'll be seeing the main activity that implements an onCreate function, and this basically loads the view itself. The view, let's inspect that for a minute. It says some XML that contains a text view. So we are getting reference to the text view over here, and we are setting the text property to our greeting message, right? So the greeting itself over here is actually imported from the NL Open Value Meetup shared package. So that comes from the shared folder we have seen before. So that also means that in the build file, there's a dependency on the shared project, as you can see. So when we are starting our app, this is the Android emulator. Okay, so this is our Android app. It shows the hello message, the greeting with the platform 29, and that works perfectly fine. So let's switch to the iOS app. This is how it looks. My Android Studio, you can of course open the Swift files, but that Android Studio doesn't know how to handle that. So we'll be using Xcode, just Xcode, to open the iOS app. And here we go. I go to the Open Value Meetup directory. We open the iOS project file, which is generated as also. This is Xcode. In the top left, you'll see the iOS app. I'll click on that, and then you can see all the properties regarding to the iOS app. In the framework section, this is basically the dependencies, as you know, for as we have seen for in Gradle. So we're depending on the shared framework. And then in the content view, that is actually where the magic happens. We see that the greeting class is created, and we are calling the greeting function on that, and that returns a string. That string is set via this way on the view, and that's basically it. Let's run it. Instead of going for the iPod Touch, we'll be going for the iPhone 11 Pro Max. It's not the latest anymore because we have the iPhone 12s nowadays. The emulator is starting. Here we go. Okay, and this is our greeting message. Hello, iOS 14. And let's go back to Android Studio. Let's make a quick change in our shared code. We are going to change the platform. Over here, let's say, hello, this is my very first meetup. Typo, save it, back to it, make a new build. Build that works itself, and when the app is run, then we'll see our message. So that works actually pretty well. Let's go back to the presentation. Because is multi-platform mobile then the golden bullet for your project? You might be wondering.